Hi everyone. Today we are going to talk about the new course Design of Reinforced Concrete Structural Element. The main objective of this course to provide the learners with the knowledge for the design of reinforced concrete members using the different design philosophy, especially for the working stress method, ultimate method, and limit state method as per the IS code provisions. And also, the learners will be helped to understand the analysis and design of the various structural component members like beams, slabs, staircases, columns, and footing subjected to a various type of the loads, including the shear and bending moment and torsion for a safe and economical consideration. So entire course is going to discuss about these topics only. So entire course we are going to split up into 5 modules. These 5 modules describe each and every module in the different parameters. Look at into the module one, the method of design of the Congress structural members. So here, this module exclusively going to discuss about the design philosophy of the Congress structures using the walking stress method, ultimate method, and limit state method. Based on this philosophy of the method, how we are going to design the structure. The basic fundamental concept only going to discuss about this module one. Then module two, design of the flanged beams is comprised of the L beam and T beam. Further, we are going to design, analyze the design of the shear as well as the torsion of the members. Module three is going to design the different type of the slabs, including the one-way slab and two-way slab, including the different type of the staircases exclusively for the dog-legged staircases. So module 4, we are going to design the columns. The columns we are classified in the axial loaded column, biaxial column, and uniaxial column. So these type of the column we are how to going to analysis and design with the, various reinforcement details. On module 5, we are going to design the design of the footing, including the wall footing, as well as the with axial loading and eccentric loading for isolated sloped footing and combined footing. So this is module 5 we are going to discuss about. The entire module 1 to 5 is going to briefly we are going to give for the learners how to design the various concrete members. So the main objective of this course is learners to understanding the behavior of the concrete as well as the steel based on the loading conditions. Okay, when a loading is applied to the structure, how the concrete as well as the behavior is happening inside of the member, that fundamentally all the learners should know before going to for analysis and the design of the concrete structures. So main second objective is learners to apply the various type of the methods are available. What the recent method is what we are going to use. If you see the walking stress method, after the walking stress method came for the ultimate method, now we are going to use it for the limit state methods. Okay, we should know milestone of the different methods, and all the methods we need to know about the as per IS 456 standard codes also we should know what the parameters of what is going to deal about. Then learners should analyze the structure to find the loads, shear forces, and bending moments for the various type of the load. Because once we know the bending moment as well as shear force only, we can able to give for the reinforcement details also. That's why we should know about the based on the cantilever beam or a simply supported beam or a continuous beam, what else the beams will be there. We should know about the various shear forces as well as the shear force diagram and bending moment diagram. Where is a maximum bending moment, where is a minimum bending moment, where is a negative bending moment. Everything we should know before going to start the process of the reinforcement detail. So based on the shear forces and bending moment only, we can able to provide the where the minimum reinforcement and maximum reinforcement, where the positive reinforcement and where is the negative reinforcement we can able to provide. Based on the we should know about the shear force and bending moment conditions. The learner should know basic fundamental design of the RC element like a RC beam, a slab, and column and footing. Then we should know about the learn the reinforcement details. So we know the different type of members. All the members we should not provide the same type of the reinforcement like this. Each and every structure having reinforcement details will be totally different. So we should know proper detailing and as well as your drawing and practical condition what they're using. Okay, that we should know how to apply for the practical concentration. So these the main objective of the this courses. We are going to learn each and every module. Then we can able to design the various Congress structural elements. Okay, what is the outcome? End of the courses, okay, as a learner should know understanding the behavior of the concrete as well as steel in the role of reinforced concrete structures. When how the concrete as well as the steel going to resist various type of the loading system as well as the shear and also the tension or the combination ensure the strength as well as the durability of the structures. The further, a learner should apply the design principle as per the Indian standard codes, especially for the IS 456, especially for the design methods of the working stress method, limited method. Okay. Then learners to analyze the structural members and also you can able to determine the maximum bending moment, axial forces and shear forces, where is going to happen, what type of the reinforcement you can able to provide in the various type of the beam, everything you can able to know after completion of this modules. Okay, and then you can able to know how to design the singly reinforcement as well as the doubly reinforcement slabs. In the slab is a one-way slab, a two-way slab, cantilever slab and continuous slab and as well as the footing. Okay, all the reinforcement you can able to do. So finally, you can able to provide the proper reinforcement detailing on the structural drawing for a practical application. So we end up the courses. We are discussing each and every module in very briefly. From the fundamental to the reinforcement details. So end of the courses, you can able to understand what is the design philosophy of the concrete structure, how to analyze the structure, how to design the structure, how to provide the reinforcement as far as the practical application you can able to. So learners, definitely I am giving the confidence to you. You can able to learn these courses. It's a very, very important courses for the field application point of view. Okay, so module one, what is the module one going to discuss about the method of the design of the Congress structures? Okay, so we see normally we are using for earlier for the working stress method. After working stress method, a new discovery will be started for the ultimate method. And now, as of now, we are using for the limit state methods. Okay, so these three methods we are going to discuss in the clearly in forthcoming these slides. So first one, concept of elastic method and also the limit state method, and then how to design the singly reinforcement beam. Then what is the advantage of the limit state method over the other methods? Then analysis and design of the singly reinforcement beam and doubly reinforcement for fundamental concept. Okay, so this is your module one. Things we are going to discuss in the clearly for the forthcoming slides. This module one objective, we are talking about the learners. You can able to understand the concept of the elastic method. Elastic method also called for modular method. Okay, under the limit state method by India RC design. Okay, so then once you know clarity of the design concept, you can able to learn the working state method as per the Indian code provisions. Then you can able to develop the knowledge for a design of the singly reinforcement as well as the working stress using the working stress method. To understanding the advantages and the principles of the limit state method over the working stress method and the limit state method and ultimate methods. So you can able to gain the ability of the analysis and design of a singly reinforcement doubly reinforcement rectangles using the limit state method. So entire this is called for main objective we are going to discuss about for this module. When you're talking about the understanding the concept of the working stress method as the limit state method, in a elastic method also called a working stress method, it is obeyed for the based on the elastic theory. Okay, so stress in the everything in the elastic limit. Okay, beyond the elastic limit we are not talking about the this working stress method. But whereas in the limit state method, it be a ultimate strength method as as we are going, this is going to deal about the safety. Everything having a limit states. Okay, now this is behavior is totally different from the working stress method that we are going to discuss in this chapter. Okay, now you need to learn in the various type of the working stresses. What is in the allowable stresses for the concrete as well as the steel. We need to check the each and every concrete structural members, check the various stress acting on the under the service to be load. Now, to ensure the stresses, everything will be within the permissible limit. When you're calculating the stresses, all the stresses we need to say for within the permissible limit. The limit is a value is given by the IS 456 2000. Okay, that port coefficient we need to check for this design of the structural members. Okay, and then we need to understand how the behavior of the structure, how the stress distribution, how the strain distribution in the RC concrete B section. Then once we know, we should can able to find out the neutral axis B position. In a neutral axis means it's a mid portion above the neutral axis B compression, it above the below the neutral axis B tension. Based on that only we can able to find out the type of the sections also. For that we can able to calculate the stresses in the concrete as well as this steel. Then we can able to identify the design of the single rectangular beam, then doubly rectangular beams. Okay, so next consider the actual strength of the behavior of the structure, and then only we can able to conclude the our structure should be economical or be a safe design. Okay, the uniform safety level in the different type of the loads and replace ultimate and as well as a now working stress method in your modern codes. Okay. As a learners, to analyze the under ultimate limit state of the method and for using the bending, shear, and deflection. Now we can able to learn for the singly reinforcement and doubly reinforcement. Okay. So what is the crush of this module is we need to strong build the strong conceptual knowledge, understanding, and practical skills for the design of the concrete structure. It will be safe and economical and code compliant for the RC design. Yeah, while coming to the what is the basic idea of the design method? When we are going to the concrete members, either it's a beam or column or a slab, whatever may be the member, we need to ask the two type of the questions. When you are going to structure, it will be a fail or not. Okay, as an engineer, we should know when I started to the construction work. Okay, whether this structure should be a safety point of view. We should take the minimum of 50 years, to be 80 years, 100 years, whatever may be the years. We as a civil engineer, we should be having a confident the structure should be a very safety. Okay, then what is the people will think about next question? This serviceability. Okay, how long it will be performed? Yes, of course it be safety. Then how it will be performed? Okay, that the two questions it should be incorrect. It should come to the everything with civil engineers. So will structure is a fail? We need to talk about the safety point of view. The structure should be more strong enough to resist all the possible loads without the collapse. Okay, even though the gravity load, it will be a lateral loads, the seismic loads, or wind load, whatever may be the loads acting on the structure. Our structure should be safe. Okay, that we having a confidence this our structure should be safety enough the entire throughout of the life of the structure. This we need to we need to check for the structures. Then will the structure to perform well in the use? We need to see this word is a well in the use. Okay, they talking about the serviceability. The structure should not be deflect or be a crack excessively and must restrained. People need to comfortable and functional during the entire life of the structure. Okay, the entire life of the structure it may be 50 years or 100 maybe years. Okay, entire years what we need to the people need to make is we need to comfortable of the structure. We should not allow the deflection as per IS code and should not allow the crack as per IS codes. Okay, that we need to come in. So the two things important when you are going to design a structure, one is the safety as well as the for the serviceability point of view. Okay. When you are going to design the piston and concrete members, we having a different type of the method is available. The first foremost familiar method is the working stress method. The further it will be a ultimate load method, and third one is for the limit state method. The three methods only were available for any type of these structures. So nowadays we are using for the limit state method. Why we are using a limit state method? What about the two methods? So what has happened? Now everything we are going to discuss about the details. The first method is called the working stress method. The structure should always remain with a safe stress limits during the for normal usage of the light. So here we need to look about the limits under the safe in the stress. So material behave elastically, no permanent deformation. That means our working stress method talking about the Hooke's law. What is the Hooke's law? Stress is proportional to strain within the elastic limit. Beyond the elastic limit of such a not in the elastic state, it becomes both a plastic state. So this working stress method is discussed dealing with only for the elastic state method. Okay, so you see the our stresses graph diagram, permissible stresses as well as the elastic ranges diagrams. Okay, so in the if you do the linear diagram, so within the elastic limits only this working stress method going to perform. After that. We cannot able to form. What is the problem? If you remove the load, it comes to the original position. So how we are going to visualize for this method? The concrete and steel are stressed only up to the safe limit. Even though after applying the concrete member, you are going to stress. That is why figure it distorts. And if you after loading also steel also going to stress. Okay, so both concrete as well as steel is going to only for up to the safe limit. Okay, where stress is a safe limit. If you talk about the like that, which is called for a working stress method. So these limits are called for permissible stresses. We never allow the structure which reach for failure condition. We cannot able to allow the beyond the forever safe limit. That is a permissible limits. Then what is the basic principle of this working stress method? It's based on the assumptions. All the structures are a structure kept in the permissible level or allowable stresses limits of the materials. What is the type of the material we are going to use here? Concrete as well as the steel. Okay. After loading started to be of the structure. For this, okay, this is be only for the permissible limits. Okay. So what is the permissible limits for a different type of the structure? Okay, be a concrete in compression, the permissible stress should become 7 to 10 Newton per mm square. Steel in the tension 150 to 165 Newton per mm square. Steel in the compression 140 to 150 Newton per mm square. So working stress method deals with the only for the stresses, everything within a permissible limit. Okay, a simple example, so analogy, like a driving is a vehicle always below the speed limit to avoid the risk. What is that meaning? We having a speed limit, okay? We need to travel within the speed limit only. If you travel the more than the speed limit, what will happen? We are going to take the avoid the risk. Same like that, our Congress structure also we need to design within the permissible limit. Beyond the permissible limit, what will happen? Our structure also be having a risk. To avoid the risk, what is the with the permissible stress? We need to design the permissible stress. So here the working stress method discuss about the permissible list. When you design the working stress method, we should assure that you're giving for a safety point of view, serviceability point of view, durability point of view, and economical point of view, whatever may be the structure. In earlier, we are designed for using for a working stress method also. Each and every member having designed for the permissible within the limit only. Okay. Then using the what is the working stress method, how we are going to design the behavior of the working stress method. Okay, beam has a steel only in the tension zone. If you consider for the simply supported beam, when you started to apply deflection, more deflection will come the midspan of the beam. When if you see the neutral axis, okay, neutral axis means the mid of the span. Above the neutral axis is called the compression. Below the neutral axis for tension for the air. Simply supported. Okay, in cantilever is a different vice versa. The top is tension, bottom is compression, and continuous slab ratio totally be different. Now we are taking here example for the simply supported beam. Above the point load will be acting on the center. Okay, for in this condition, above it be a compression, bottom it be a tension. Okay, in a singly reinforced beam, the steel is provided only in a tension zone. Tension zone means bottom zone to resist the tensile stresses. What is the meaning that in the neutral axis, above the neutral axis, concrete is there. This concrete will take for the compression load, and below the neutral axis is, even though the concrete will be there also, it won't take the load, steel only going to take, that is the tensile stresses alone. When the load is be acting, okay, what will happen? Concrete take the compression and steel take the tension. This is a philosophy, it will happen the inside the beam structure. Okay, we know the things. No, concrete is very weak in tension, so it will crack automatically from deflection will come. Okay, but steel handles this. When you started to deflection, what will happen? Instead of the concrete, the steel going to take. Now we see, look at the single reinforcement diagram. The neutral axis, above the neutral axis is a compression, and below the neutral axis will be maybe a tension. Okay, this is your second diagram for a stress and a strain diagram, and next one is a stress diagram. Concrete in the compression, steel in the tension. That's why that in below, if you see the below the neutral axis, we are not marked up to the end. We are not did, because in below that tension stresses will be occur, that is going to take for the steel only. Okay, so for working this method for a single reinforcement, we need to ensure the all stresses. Okay, it's a permissible stresses are in be safe, but does not check the actual failure capacity. We not bother about the when it will going to failure the capacity. That is only main disadvantage of the this working stress method. Then we should know about the how the behavior of the material. Okay, in concrete, and two material of the material is available, one is the concrete as well as for the steel. Okay, how the material behavior in the concrete in elastic material. Okay, when a concrete will take the more of the compression only to resist the compression well. We can able to do for give the compression load. Concrete can able to take, but reversely, this concrete will be very weak in the tension. So automatically cracks will be formed in the concrete. Now, if we look at into the steel will be a tension member. To resist the tension, it be a more ductile and it be a reliable. Working in the within the elastic limit. Now, if you give the concrete and the steel, a combination of the composite member, all the compressive load it will take for concrete, and all the tensile will be taken for the between a steel. Okay, when you're using the limiter, we having a certain limitation will be there. Too conservative uses the more material concrete as well as steel, because we don't know when it member going to fail. For that, what we need to pour the more materials, both steel as well as the concrete. Does not consider the ultimate failure condition. We don't know when it will go into failure member. We cannot able to predict for in the working stress method. So not economical for a modern structure, because when you're using the more materials, concrete and the steel, the material having a thickness is a huge material, bulk material will be we can able to do. Okay, the working stress method, what is going to say about this one? We need to check the everything in the permissible limit. Okay, concrete as well as steel, everything we need to do. So the working stress method, it will behave within the elastic limit. That means the Hooke's law. It will obey the Hooke's law. So the key idea of this working stress method is all the stresses, concrete as well as steel stresses, are limited to safe values to avoid the excess of the deflection and cracking or damage to the normal service load. Normal service load, it means when you construct the building and you started to apply the UDL or dead load, it should be perform. Okay, should not affect for deflection, cracking, and damage in the normal entire of the lifespan. So working stress method keep the structure safe in the daily uses, but does not tell about the how strong it be really is. We cannot able to strong. So that is when talking about the working stress method. Our next method is called for ultimate load method. After generation, first one is working stress method in the ultimate load method. So this ultimate load method focus only maximum load before the failure. It's maximum. When you started to apply it, going to maximum load. Before that point of the load, we can able to know, give the indication of the structure. So users increase. Okay, not what we are going to add for the factor load to ensure the safety. But in case of the working stress method, we are not using for any factor loads. Now we are using for here factor loads. When it is structure will be columns that we can able to know using for this ultimate load method. When a load reaches the ultimate capacity and the structure can no longer resist it. That's fundamental concept. If we take the simply supported beam, we have started to apply the loads, then automatically structure started to deflection. Okay, when you're increasing load, it started to deflection. What is the ultimate method? It says when a loader reaches, okay, the ultimate capacity and structure can no longer to resist, it's automatically is going to failure. Okay, up to failure maximum, it's we can able to focus. That is called the ultimate load method. But what is the main disadvantage of the ultimate load method? Is it ignores automatically cracks. It ignores the crack may form long before the ultimate load, but ultimate does not be check that, and all we not bother about check. When you started to apply to whether it comes for a cracks and deflection, whether it be comfort or not, that and all we are not bothering about the what using methods. Okay, when seeing about the deflection, excessive deflection can affect the function and appearance, but ultimate lesson method, it ignore it. Yes, of course, when you're staying in the room, we need to feel as a more comfortable in our structure. When I started to apply it, it be excess of deflection is coming. It be automatically appearance, no, which will be deflected in a beam. But in ultimate load method, that and all we're not considering. Then comfort, that needs to be a suffer serviceability, vibration and discomfort in service condition are we not considered for this one. Okay. When you know a key difference between the ultimate load and the working stress method. In the working stress method, based on allowable stresses, that is, we say the permissible stresses during the service life of the structure. Whereas the ultimate load method, based on the ultimate failure strength only, we are going to consider. Here, the working stress method they're using for the service load only. We are not adding the for the factor of safety, that is the unfactor. We are not using any factor to calculating for the service load. But whereas the ultimate load method, we are using for the factored wheel load to ensure the safety in the normal usage rate. They find the maximum load before the collapses for the ultimate load method. Okay. Whereas the working stress method does not check for actual failure will be capacity and does not consider serviceability, and cracks and deflection will be under will be comfort. When you are looking at the load and displacement curve, in case of the working stress method, it only for the linear, okay, up to the elastic limit. But whereas in the working ultimate load method, we can go for the collapse to the failures, the stages. Okay. So what is the final conclusion for the ultimate load method? Ultimate load method ensures the strength. Okay, but ignores the usability uses. That means the deflection and cracks and the serviceability that not be considered. That is a main disadvantage of the ultimate load methods. Now the reason what we are using is the limit state method. Okay, what is the core concept of the limit state method? Combines both ideas, including the working stress method as well as the limit state method combinedly. Sorry, working stress method combinedly come to the one new method is called the limit state methods. Okay, safety point of view, structure should not be collapsed, and serviceability, we know it is comfort. Okay, we need to feel for comfort. The structure should not fail and should not work properly during its day, should work properly during the lifespan of the structure. Okay. In safety point of view, if you see the structure of the diagram, whereas the working stress method and ultimate method, we are not talking about the collapse prevention. Here, the limit state method, we need to see the prevent failure under the extreme load condition also. Okay, so it's a bit easy. In apart from not only for safety point of view, and it be a need for serviceability point of view. Okay, ensure the comfort of the people and the proper function during the normal use of the entire life. Okay, the entire lifespan of the structure. If you see the limit state method, safety and serviceability. Okay, it gives for the limit state method. What is the limit state of the collapse? Okay, when you're talking about the limit state collapse, what you are in current, into whatever will be there, you need to check into the bending as well as shear as well as the compression. It be ensured that our structure should not fail the bending, our structure should not fail in the shear, the structure should not fail in the compression. Okay, so when you're looking into the loading in the real will diagram, check against the ultimate loads to prevent the collapses. Okay, what is the limit state of serviceability? They ensure the structure is comfortable to use, less for less deflection and be less cracking and less vibration. Okay, so exclusively limit state deals about the safety as well as the serviceable point of view. In the safety point of view, we need to ensure the structure with a bending, shear, and compression. And serviceability point of view, deflection, cracking, and vibration we need to check. This both combination structure is called for the limit state method. So automatically we need to assume the loads may be higher than the expected. What we had is an expected that the load will be higher. We need to take and assume in the limit state method higher loads. Then material may be weaker than will be expected. So it will introduce a safety margin or elastic. Here we are going to use for the factor of safety for that. Okay. Summary of the limit state method approaches. So limit state method of the collapse, the safe against the failure. Check strength, bending, shear, as well as the compression. We need to collapse. We need to check. Limit state of the serviceability, the comfort we need to check, and the proper function. The control deflection, cracking, and should be a vibration. So overall global point of view, if you see the limit state method, our structure should be either should be a fail or causes discomfort throughout the village. That means we need to feel a comfort to the structure. So limit state method it provides balanced design by ensuring both strength as well as the usability of the structure. So hope the learners we are briefly discuss about the three methods. One is for a working stress method, and the ultimate load method, and limit state method. So now recently, now what we are using in the limit state method, it's a very predominantly using the limit state method. We are having a more prawns when compared to the other methods. So limit state methods deals about the safety as well as the serviceability point of view. So what is the major the difference between the working stress, ultimate, and limit state method, various design aspect. When you see the basic fundamental concept of the all the three methods, in a working stress method, it's based on the permissible, allowable stresses only, whereas the ultimate led method, strength of the structure and the excess of the loading. When you're talking about the limit state method, based on the limit state, both the strength as well as the limit state, each and every point having a limit. You take the crack, you take the crack, having a limit, having a deflection, having a limit, either fatigue or vibration, everything having a limit. That there should not cross the limit state. That is talking about the limit state method. What is the primary focus of this all the three methods? Here is the focusing in the working stress method will be stresses. So it will be safe stresses during the normal uses of the structure. In ultimate loaded, maximum loads before the failure is going to focus mainly. So, but in case of a limit state method, it's going to focus on both safety as well as the serviceability point of view. When you condition for load used, the service will be unfactored. We are not using for any factor of safety, factor, non-factor load only need to consider. That is called service load. Okay. But in case of the normal load, for factor load, we are going to increase both for steel as well as the concrete. We are going to use for the factor load. So here the factor loads with the load combination, either it be a dead load, live load. Apart from that, dead load plus live load. Apart from that, dead load, live load, wind load. Then live load, wind load, and earthquake load. We having a different form of the load combination as per IS codes. Based on that, we can able to give the factor loads also. Okay, we need to check performance. When you're checking the performance of the working stress method, the stresses less than or equal to for the permissible stresses. Each and every having a different type of this permissible stressor, whatever we are calculating should come the less than or be equal to the stresses. When you're checking for the ultimate load method, the resistance capacity will always be greater in the factor load. Strength check only. When other than that, we are not checking. Now here, what will happen in the limit state method? We are checking the both strength as well as the collapse point of view and serviceability and usable point of view. We are going to check for the in limit state method. Okay, what we are going to consider in case of the working stress method, material behavior is the elastic behavior that we are saying the Hooke's law. Okay, but in case of the ultimate load method, the material non-linearity until the failure. Okay, that is the curve should be coming non-linear up to maximum load. What is the maximum load taking that we need to consider. In the limit state method, the material non-linearity also we considering, safety factor being increased, long-term behavior, uncertainty, everything we need to consider here. What is it we need to consideration here? Because elastic behavior is material non-linearity still will be failure will be there. Okay. What is to be ignored and does not be ensure here or here? In case of the working stress method, actual failure capacity, then servicity, deflection, cracking, vibration, comfort, we are not ensuring. We are ignoring. We are not calculating. We are not considering these factors in the working stress method. Whereas the ultimate method, we are ignoring the serviceability. That means deflection, cracking, vibration, comfort, behavior of the normal use, everything we are going to ignore in ultimate. But whereas the limit state method, we're not ignoring everything, we're taken into the consider both safety as well as the serviceability point of view. In safety point of view, which one is we are giving the more moderate? Safety point of view, moderate in case of the walking stage method. In ultimate method, it be high strength for the strength only. For in the limited method, high for both strength and serviceability also. Okay. For economical point of view, less economical, it will be conservative in case of the walking stage method, because that's why we cannot able to calculate in the loads materials also. When you're talking about the walking stage method, we are more materials we are going to use. So it will be less economical, more economical, strength based point of view only. Okay. But when strength point only, we are going to use the materials is more. So strength point of view is good for an ultimate method. Most economical is optimized design in case of in the limit state method. Okay. Typical uses. Because in earlier all the structure we are designed for the working stress method only. Older construction and a simple structures we are using for the working stress method. Now, special structure, especially for a military structure or in the practice, whatever maybe we are using for the ultimate load method. Okay. So in modern uses of the bridges, high-rise building and industrial structure, all these structures nowadays we are using for the limit state methods. Okay. What's the key idea, fundamentals of the working stress method? Keep stresses, all the stresses within your safe limit during the entire safe life of the structure. But here we are not considering the check actual strength as well as the serviceability. This is one disadvantage of the working stress method. Here in the ultimate load method, they ensure the strength against the collapse using the ultimate loads, but ignore the comfort as well as the usability in the ultimate load method. While coming to the limit state method, ensure the structure does not fail and also works properly during the life in terms comfort as well as the performance. So, dear learners, it's the overall the view of the different type of the method, working stress method, ultimate state method, and the limit state method. We are clearly discussed about the basic fundamental concept of the three methods. What is the three method? The focusing, how the behavior when you're using the load, what are the checks we are performing in all the three methods, what we are considering, what we are ignoring, what is a safety point of view, what is the economical point of view, where we are using typical uses for all the three methods. Finally, we are concluding limit state method, one of the extraordinary method where you are using for the construction of the structures. Okay. Now we are going to discuss about the behavior of the beam under the load. When you see taking the example of the simply supported beam, if you not apply the load, what will happen is looking like a stable one. Okay. When you started to apply load, beam started to bending. Here is a simply supported beam, so the maximum deflection will be it will be a sagging bending moment. Okay. Now we need to draw the neutral axis, that is we call for N and N dash. After bending, also plane should be a constant. Okay. That we need to say for A dash and B dashes. Okay. So here the figure A says for beam before deformation, after the applying load is after deformation. Above the neutral axis is called for the compression zone, and in compression zone it is fine having a maximum compression zone. Then it's below that be tension zone, and midpoint having a maximum tension zone. Okay. Now here you see the two type of the section. One is a cracked section and be uncracked section. What is the uncracked section? Both concrete as well as steel within the elastic limit. Okay. Then it is called for a uncracked section. That means crack won't be come. The stress diagram will be linear. In also both in compression zone and as well as the tension also be it be same. That is called the uncracked section. What will happen here? Cracked section, either steel or the concrete reach the permissible value. Okay, that is a crack will come for it. Will come, that is called a cracking section. Then we are going to discuss about the different type of the failure. It be compression failure and tension failure. This systematic diagram. Now we are going to discuss about the one by one for the all the major of the structures. Okay. When we are going to start to apply how the beams are going to behave under the loads. When a simply supported beam is subject to a transverse load, that is to a vertical load, automatically it bends. So once a bending, what will happen is causing the compression at the top of the section and tension in the bottom of the section as is shown in figure in board. When you see the simply supported beam, we have started to apply the load, started to bending in between the dotted line is called neutral axis. From the above the neutral axis called the compression and below the neutral axis we have tension. It is called the stress distribution for a rectangular beam. What the second point is the section rotates above the neutral axis, that is called N and S after the loading applied. But the plane is here constant. The plane after bending will be also okay. So before bending, nothing will be happen. When you started to apply load, which will be a new N and S it will be started to rotating after the plane bending. Okay. So N is the neutral axis. The color shows the clear. Blue color shows the comfort zone and red color shows the attention zone. Okay. How is it going to behave here? Now see the third point. When you have small loads, stress in both compression and tension zone are within the elastic limit. The stress distribution should be a linear. What is it? Both compression as well as the tension it should be linear. Both will be same. When it will happen? Because of the stresses, because of the small loads. Yes. Okay. So here we see the stress and strain diagram. The concrete will be lower stress strain diagram, and the steel will be more high, but in the elastic limit. A load increases, and tensile stresses in the concrete reach its a limit. Okay, and cracks into form and reinforcement then resist the tension. Yes, of course, normally to the applied load. Now the load increases, the tensile stress concrete reach in the limit. Where will the tension get? In the bottom of the section. Once the concrete reach the permissible value, next material will be steel. Okay, the steel only going to take for the tensile strength because it's going to arrest the crack. Okay, so before the cracking, now see the diagram. When your load will be increasing, okay, found the tension zone, tension strength concrete will be reaches, then automatic crack will form. Once crack will form, which material going to take? For the steel only going to take the all the loads. Okay, though in compressive stresses diagram becomes a non-linear and also positive deformation started. It begins when your load is small. The stress is the limit both in the compression as well as the tension. When your load is increases, okay, then the test diagram should be a non-linear stress function diagram. Okay, what is 6.6? When you are using further, it will be loading. Okay, the compression zone may be failed at a first, so it will be happen for the over reinforced section in the brittle failure. Okay, the compression concrete reaching the ultimate will be a strain when your load is will be high. It's one cause of the failure. That concrete crush suddenly. Where it be concrete will be then in the topmost above the neutral axis. It will be crushed. It will be a suddenly. This failure is called a brittle when a little warning. So give the small warning, it will be little failure. If the tensile steel yield first prior to the concrete, this type of the failure is called under reinforced section. It will gives the warning under the long deflection occurs the failure to be ductile behavior. So whereas the tensile steel yield and elongated. Now before prior to the concrete, now steel stresses started to yield and will be elongated. When it will be large deflection will be occur. The concrete compression is still in the stable. Okay, the failure will be ductile within giving the more warning systems. Now, balanced section occurs both stress in concrete as well as steel reached simultaneously. Same time, stress in concrete and steel reach the permissible. That is failure is called balanced failure. But over reinforced beams fail suddenly because we are providing the more reinforcement. It won't give any proper warning. Small deflection then started to be failure. That failure is called brittle failure. So what will happen here? The compression concrete crush very first. and which is very small deflection will be occur, then it will be started to failure. It won't give any proper warning system, and failure will be sudden and also be very brittle. Whereas other failure is called under reinforced beam. It shows the large deflection before failure. This failure is called the ductile failure. What will happen here? The tensile steel yield and elongated. Okay, then it will shows the long deflection and the visible cracks also we can able to see. Now, failure is a very ductile. It gives the clear warning to the people. Once if you know the warning, we can able to remove the loads. Okay. So design the structure of the failure. We need to prefer the under reinforced or the balanced section as a reinforced concrete beam for safety and warning of the before the class. So for any class, we should not assume for the over reinforced section. Okay. Then we look at for the design of the singly reinforced beam using the limit state method. Okay, steel is provided only for tension. Yes, it is a simply supported beam. We are going the steel in the bottommost because tension will be occur in the bottom, and above the neutral axis will be a compression. Okay, for to resisting tensile, we are providing the tension at the tension zone. Okay, if you give the more load in higher load, steel start the yielding. If stretches, be full stretches started to yielding. The concrete is the compression. We having two material. Concrete will take the compression and steel will take the tensile stresses. Okay, so we need to start. We design the steel yield first, not concrete or the crushing. Clearly we need to see. Okay, when I started to design the single reinforcement. Okay. Beware of the loads, no service load, the steel and the concrete both need to be elastic. That's why we are seeing this strain diagram also. Then after applying the loads, steel started to be yielding. The steel yields to be stretches. The concrete steel will be compression. It will not happen any failure. When you're going to look at into the ultimate load, steel yield will be fully and concrete will be still in the safe. In compression, failure occurs in the steel. Okay. Why? The steel failures give the warning it be a ductile. Okay. If you want to go to the failure, small deflection will come because the steel stretches, then started to bending also. Then crack will come. Then disintegration of the concrete material, then falling of the concrete cover. Then we can able to understand this number going to failure. Then we need to remove the load, it will come to the open position. So this much of the warning system will give for the ductile material. Whereas of the brittle material, it won't give the any deformation, just a sudden failure. It will be called the brittle failure. It won't give the any warning system. What will be the result now? What you will see? It ensure that safety and predictable failure in case of the single reinforcement beam. The beam shows visible signs and before collapse and giving the time to taken. So we need to design for only for balance as well as the under reinforcement failure. So whatever may be the failure, we need to consider two type of the failure of the beam. One is for a ductile. It's a designed failure and brittle should be avoided when you design. Okay. Now, what will happen in a ductile failure? Steel eat and started to be elongated. A large deflection will form and we can able to see visible warning because of this cracking system. So it be safe and we can able to easily predictable. Whereas in a brittle failure, concrete crushes to be suddenly. We won't give the any warning system. It be sudden collapsible. It's more dangerous and unpredictable for the structural failures. What is the key for while designing a reinforcement? We need to design for a steel should be yield first, not in the concrete or the crushing, for a safe and reliable of the structure and the design of the concrete beams. How the behavior of the W reinforcement is. Okay, beam depth cannot be increased height of the restriction. Yes, of course. When you start to structure in the longer span, we can't able to provide for the huge the beam time. Okay, we need to restrict because of the structure which will take for more high load. For that, we cannot able to increase the beam size. When you started to increase the beam size, what will happen? The space will be started to minimize. The appearance also going to reduce. For in that point of view, in that consideration, we need to go for doubly reinforcement beam. Okay. The reinforcement we can able to provide both the section and compression as well as the tension zone. Okay. What is the key concept of the doubly reinforcement section? It still is provide the tension zone as well as the compression be concrete. How to behavior of the loads in case of single reinforcement. Concrete in the compression zone carries the compressive forces. At high loads, concrete may crush and limited the strength. Whereas the doubly reinforcement beam, concrete and compression steel share the compressive forces. Concrete is the compressive load. Now you see, in above the zone, concrete also will take the compressive load and steel also will take the compressive load. And higher strength and better performance under the very high load for the doubly reinforcement section. What is how the behavior in doubly reinforcement? Concrete alone cannot be handled the high compression because it will compress very easily. This is a brittle. Okay. Okay. For that, what we need to do, we need to provide the compressor steel in the top. Okay. When you see the compressor steel, what will happen? The compressor steel will take this shear load along with the concrete member and automatically increasing the strength and improve the overall performance of the structure. In a doubly reinforced beam, used when a single reinforced beam not in sufficient time. Okay. How the load will be shared? We are providing above the neutral axis the compression steel as well as the tensile steel. In concrete also will be compression. Apart from the concrete compression load, steel also going to resist the compression load as well as the steel also will be taken in the tensile load. Now all the materials taking for loads. In the bottom section, the tension is taking for tensile load. In the top section, above the neutral axis, both concrete as well as the steel also will be tension. Why we are using the limit state method for the double reinforcement to ensure the safety at the failure. Structure will not collapse suddenly. Okay, it will give the warning system and also we ensure the comfort in the usages. It will control for deflection, cracking, and vibration. Okay, that is everything it will control in the double reinforcement section. So here, considering both strength and the serviceability point of view, we will get the balance and reliable design we approach for the doubly reinforced chicken. So what is the fine rule? When you're using the limit state method for the doubly reinforcement, ensure the both safety at the failure and comfort in the uses. Okay, for the doubly reinforcement. Big. So this is a module we discussed about the very fundamental design of the methods and how to design the singly reinforcement and doubly reinforcement. Now the learner, what you understand that you can able to explain the various basic concept of the working stress method, ultimate load method, and limit load method for a concrete design. How the behavior of the structure using for the working stress method, ultimate and limit state method. Now learner, you can able to apply the working stresses method using the IS score for design of the concrete member. Now you can able to know what are the permissible stresses in the steel as well as the concrete service load where you can able to use and various stresses in concrete as well as steel. Everything we need to keep it as a permissible limit. Now we can able to know where we need to use for factor of safety. With the method we cannot able to use for factor of safety. Now you can design for the IS 456 like that. Okay. Now you can able to design the single reinforcement beam using the working stress method. Now you can able to design effective depth and various section properties. Now you can able to calculate the maximum bending moment under the service load. The find you can able to do for a requirement of the using steel area. I can use for the different type of the formula. You can able to check the stresses in the concrete as well as the steel. Now you can able to evaluate the advantage of the limit state method over the other methods. Okay. Now you can able to explain can you understand that considering actual material strength, okay, and based on that better safety and reliability and economical and efficient designs and applicable to all the load combination and replacing working stress method ultimately in a modern course. You can able to comprise the different aspect both all the method working stress method ultimate load method in a limited method. Okay, when the basic concept working stress method deals about the only working stresses. Okay, ultimate load method deals about the working load method and limit state for the everything and limited load here considering only for service load. In ultimate load, we are considering for ultimate load, but here we are using for factor load. In safety point of view, we are using by factor safety. Ultimately, no factor safety. Here we are using for the partial, okay, safety factor. When you consider about the aspect for the material strength, not fully utilized in the working stress method, fully utilized, but limited what we need for it to optimize. Okay, when talking about the economical point of view, working stress method is a less economic. In ultimate load is the uneconomical, more economic in the limit state method. What is the core status? The old method only using for the core status, old method, ultimate load. So now we are using limit state for current IS4 basics only we are using. So briefly, now especially we need to conclude that apart from the two method, we are having a more advantage of the limit state method. Limit state method is a more preferable. Learner, now you can able to design the singly as well as the doubly reinforcement concrete beam using the limited as well as the working stress method. Okay. Now you can able to analyze for a limited method, design the bending as well as shear, checking for a limited of bending, shear and deflection. You can able to design the singly reinforcement and doubly reinforcement wherever you can able to design. Then you know how to reinforcement provide for singly reinforcement and doubly reinforcement. Okay. Now we can understand that you can able to more strong in the conceptual understanding and practical skill and safe economic core combined for the design for this module one. Okay, so you can able to refer various different textbooks also be available in our libraries. Okay, one of the prominent books, Design of Reinforced Concrete, using the latest course IS 456 2000, Krishnaraju. It's now it became for the sixth edition also became. Okay. Next, the most familiar professor, the S. Unikishan Pillai and Devadas Mason, written by Reinforced Concrete Design. Okay, we can use these two books. Okay, it's available in our library. Also, will be there. Okay. Okay, we can able to design on all the fundamental concept in the reinforced concrete design. Okay, thank you all. Thank you for all the learners for the module one. The module one, we have discussed about the elaborately various methods of the reason for the Congress churches members. Okay, very soon we are going to discuss about the next module for module two. How to design the flanged beam, that is the L beam and a T beam, how to design the structure that we can see, then how to design the shear as well as the torsion of the beam. Okay, okay, thank you for all to attend the your attentions. Thank you very much.